In this next section, we're going to be looking at equations that have variables on both sides. This adds one extra step in the beginning stages of our process. We'll still start with simplifying both sides separately, combining any like terms if we can, but then we'll add in a new step where we either add or subtract something to both sides so that we can get all of the variables on one side and then all of the constants on the other side. Then your last step might be to multiply or divide to get the variable by itself. So here's our first example. 7x plus 19 equals negative 2x plus 55. 7x plus 19 has no like terms, neither does negative 2x plus 55. So there's no simplifying to do in the first step. The next step is to get all of the variables on one side. It doesn't really matter whether you move all of the variables to the left or the right. You'll get the same answer either way. Your work just might be different than someone else's when you go to compare. So what I'm going to do is I'm going to try to move all of my variables to the left. The 7x is already there. I'm going to try to move the negative 2x by using an inverse. So what I'm going to do is I'm going to add 2x to both sides so that I can eliminate this. Negative 2x plus 2x would be 0, and essentially that would cancel out and just leave me with a 55 on the right-hand side of the equation. On the left, I've got the 7x plus 2x, which is 9x, and I still have the plus 19. Now that I've got all of the variables on the left, I want to get all of the constants on the right, which means I need to get this 19 over to the other side by using an inverse. The inverse of adding 19 is subtracting 19. 19 minus 19 is 0, so I'm left with just the 9x on the left. It's almost like those 19s canceled out. On the right-hand side, I've got 55 minus 19, which is 36. And I'm getting very close to what I wanted. The inverse of multiplying by 9 is dividing by 9. 9 divided by 9 is 1. 1 times x is just x, so it's sort of like those x's are canceling out. On the right-hand side, 36 divided by 9 is 4. So my answer is x equals 4. Don't forget to do a quick check. Go back to the beginning of your problem and rewrite it, but replace all the x's with 4s. So instead of 7 times x, 7 times 4, plus 19 equals negative 2. Instead of negative 2 times x, negative 2 times 4, and then plus 55. Use your order of operations to simplify. And we end up with 47 equals 47, so I know that my answer is correct. Let's do one more. 80 minus 9y equals 6y. First step is to simplify either side of the equation if you can. In this case, there are no like terms on just one side of the equation. The next step is to get all of the variables on one side of the equation and all of the constants on the other. It looks like I already have all of the constants on the left, so it's going to be easiest to get all of my variables on the right. And the way I would do that would be to use the inverse of negative 9y, or subtracting 9y. The opposite of that would be adding 9y. Negative 9y plus 9y is 0, so it's sort of like those cancel out, and I just have the 80 left over on the left. And on the right, I've got 6y plus 9y, which is 15y. 15y means 15 times y. The inverse of multiplying by 15 is dividing by 15. And 80 over 15 doesn't work out real nicely. It is a fraction, but it reduces to 16 thirds. So my answer is 16 thirds. Now, in terms of an improper fraction, this is probably the best way to leave your answer, just because you're less likely to make mistakes. But you could also write it in equivalent forms. So it would be equally correct to change 16 thirds into 5 1/3, and it would be equally correct to write that as 5.3 repeating. However, it's probably just easiest to leave it as the 16/3. Last thing we want to do is a quick check, going back to our original problem and substituting the 16/3 in for the y and simplifying using our order of operations. And I do get a true statement. 32 does equal 32.